ready for some fun stuff here. The sum and difference identities for cosine. And if you've looked ahead in your notes at all, you'll know we also have sum and difference identities for sine. And we have sum and difference identities for tangents. Your sum and difference identity for sines and cosines are important. Tangent is probably not as essential to have memorized, especially we're going to see an example today where we can use our sine and cosine identities to help us find the tangent identity. So if it came down to it on a test and you needed the tangent identity and didn't remember it, you could use the sines and cosines to find it. So let's just start with cosine, okay? So the sum and difference identities for cosine are where we can use two angles to add up to a different angle or two angles to subtract to get a different angle. This allows us to find other angles besides 30, 45, 60, 90, and so forth and so on. For example, look at the example 3. We're supposed to be finding the exact value of the cosine of 15. That's not one of the ones we know already, but we can use an identity to help us find that. So to help you memorize this, though, before we do this example, because yes, you definitely want to memorize these, I had some students, I learned this somewhere from someone at some point. Let's think of cosine as an individual, and cosine is kind of cocky, kind of a cocky individual. Cosine likes to put themselves first. So notice how both of our formulas start with cosine. In fact, cosine just steals the show to begin with. We have cosine twice, and then sine just follows up behind. Okay, so cosine's kind of cocky, puts themselves first. The other thing about cosine is that cosine's kind of contrary, because, you know, a little rebellious, like do the opposite of what you tell them to do. So this has an a plus b, but this is the opposite. It's a minus. A minus b is the opposite. It's a plus. So cosine is cocky and contrary and just likes to not follow instructions. I don't know. The sillier you make your ways to remember things, the better you're going to remember it. So let's do this. We've got the cosine of 15 degrees. The easiest way to find that is going to be by using a difference identity, by subtracting. So the cosine of 15 degrees can be found by doing, the obvious one to me seems like doing 45 minus 30. I mean, we could do 60 minus 45. We could do second or third or fourth quadrant angles instead, and they would still subtract to get 15. So anything you choose will get the same answers, but then you have to worry about negatives and things like that. So just pick something that's the easiest for you. So using this identity, the difference identity, cosine is cocky, we're going to put him first. So cosine of 45 times the cosine of 30. And we're saying please subtract, so cosine's going to be contrary and say no, I'm going to add instead. So sine of 45, sine of 30. So they stay so that you have alpha, beta, alpha, beta. So your first angle, then your second angle, first angle, second angle, right? Okay, let's evaluate these. We have these memorized. The cosine of 45 is the square root of 2 over 2. The cosine of 30 is square root of 3 over 2. I should have made you do your little trig chart today just to review these. The sine of 45 is square root of 2 over 2. And the sine of 30 is 1/2. Let's multiply those together and simplify. We get the square root of 6 over 4 and the square root of 2 over 4, which adds up to the square root of 6 plus the square root of 2, all divided by 4. Kind of an ugly answer, but there's an exact value for the sine or the cosine of 15 degrees. Just for fun, you could throw that in a calculator. Let's see, the cosine of 15 degrees is, just for fun, calculator here. Calculator fun, I'll just call it, because math is fun. Calculator fun, the cosine of 15 is 0.96595, blah, blah, blah. I have more decimals than that, but anyway, I'm going to go ahead and try and figure out what this is. So the square root of 6 plus the square root of 2 gives me like 3.8637033305. I'm going to divide that by 4. Well, look at that. I got 0.965925 and so forth and so on. The calculator and my formula and my calculations agree with each other. That's a beautiful thing, don't you think? So the advantage of doing something like this is you have an exact answer, which is sometimes helpful depending on what you're doing with it. Okay, let's look at another use of our cosine difference identity. For some reason, both of these problems have differences in them. Instead of letting us practice the sum identity, but that's all right. Okay, so we're going to start with our left-hand side again. So we're starting with the cosine of pi halves. That's weird to have an actual angle in there instead of just a variable theta. We go ahead and use our difference identity. So that would be the cosine of pi halves times the cosine of theta. And cocky contrary cosine is going to use a plus for a difference. So that'll be the sine of pi halves times the sine of theta. Well, now let's go ahead and simplify. We know the cosine of pi halves, or the cosine of 90 degrees, don't we? If I visualize it on my unit circle, 90 degrees is right here, and that is at a point 0, 1. And cosine is my x value, and sine is my y value. So cosine of 90 is 0. So 0 times the cosine of some angle theta. And then sine of pi halves is 1. So 1 times the value of some sine value theta, right? 0 times anything turns into 0, and 1 times anything just stays that thing. Well, look at that. Like I said, sometimes I probably write more than I need to, but I'm just trying to make sure you know exactly how I got to that destination. So I've verified this identity by using the difference identity for cosine.